All right, good afternoon, grade sevens. I hope that you guys are all doing well and that you're having a great week so far, guys. I hope that it's been productive in the best way possible. Um, we're back again for another lesson, guys. Unfortunately, as you can see, the grade six and seven lesson for this week did unfortunately have moved up ever so slightly. Uh, and this was just the result of some unfortunate power outages, my side of the world, that were unfortunately way beyond my control. But nonetheless, guys, we have some time to dedicate to understanding a little bit more about a topic that I think you guys have been enjoying now. For the past 2 or 3 weeks, we've been chatting about the coordinate plane grade sevens. And during this time, I think there's been a lot of questions from you guys about, you know, how the topic works, where we use it, and so on and so forth. And it's really cool to see that you guys are taking a liking to this topic because it actually is a lot of fun. And yes, like we discussed 2 or 3 lessons ago, guys, this is also a topic that is going to be used in a wide variety of other sort of sections that you're going to learn about in high school a little bit later on. All right. So, guys, I think it's about time that we get going with today's lesson. Today's lesson is not going to be super long. It's just going to be us wrapping up our understanding of the Cartesian plane, or what we call the coordinate plane. So I'm going to start by sharing my screen with you guys. We're going to get going. But please don't expect today to be a very extensive lesson. This is actually a lesson dedicated to just finally wrapping up the last few things that we need to know about as far as the Cartesian or the coordinate plane is concerned. All right. Okay. So, guys, you should be able to see me scribbling on my screen in many different colors. We have yellow, orange, green, and even blue. Right? It looks like you guys can see all of that. So please make sure you let me know if there's any problems with seeing what I'm writing or hearing what I'm saying during the lesson, grade sevens. Today's date is the 30th of May. Um, and our heading is going to be quite a long one today. It's calculating distances on the Cartesian plane or on the coordinate plane. Okay. So before we go into writing down a whole lot of information, guys, about how we calculate distances on this coordinate plane that we've been learning about for quite some time now, I want to go and take a look at the actual coordinate planes that we've been using over the past few weeks and actually show you visually what I'm really talking about when I say or speak about calculating distances on the coordinate plane. All right. I see a few more of us have joined, so welcome to all of you that are just joining us now, guys. Right, so let's quickly take a look at one of these coordinate planes. Right, we know what these look like now. We've chatted about them for a few weeks. And first things first, we have our x axis, which we're going to highlight in yellow. And we have our y axis, the vertical axis, which I'm going to highlight in orange. Right. So I'm just going to use this slide as an example, guys. You're more than welcome to copy down whatever you see fit. Okay. So let's take a look at this coordinate plane in a little bit more detail. We know that the horizontal axis, like we've just mentioned, is our x-axis, and vertically moving from top to bottom, we have our y-axis. So last week we spoke a lot about how we go about writing coordinates, grade sevens, and we said that coordinates are a way for us to identify exactly where we are on the coordinate plane, right, with more accuracy than we might be able to do with other methods. And a coordinate is always a set of two numbers written in the form x then y, which represents the x value of that point and the y value of that point. Okay, so for example, if we looked at this point right over here, you guys would remember that in order to find the x value for our coordinate, we start by lining up this dot with the x axis. And we can see that we line up with the value positive 5. So the first part of this coordinate is positive 5. And in order to find the y value, we need to line up with the y-axis. And you can see, lining up with the y-axis, guys, that we are at a height of positive 3. So this coordinate, or this point that we've looked at, has the coordinates 5, 3. Right? We're going to practice one or two more of these very quickly. Let's say, for example, we had another dot down over here. At the bottom left-hand side of the screen, again, if I want coordinates, it means I'm looking for the x value, which we are associating with yellow, and the y value, which we are thinking about in terms of orange. So to find my x value first, I need to line my dots up with the x axis. And we can see that we line up with the value -3, right? -3. So the first part of this coordinate is going to be an open bracket with the value -3 in front. To find the second part, which is the y value, we need to line our dots up with the vertical y-axis. And we can see that we line up with -6 on the y-axis, grade sevens. So our coordinate for this point over here is going to be -3, -6. We can call this point B. This will be point A. Point A and point B. Let's do one last number over here. We can do this point here. We'll call it point C in the bottom right-hand quadrant, quadrant 4 of the coordinate plane. Right. In order to find the coordinates, I need to find the x value and the y value. In order to find the x value, I'm going to line my dots up with the x axis. This shows me that we've aligned ourselves with positive 10. Please make sure that you are careful with your positive and negative signs. All right. Positive 10 is the dedicated x value for point C. So we put the number 10 in brackets. But now the second part of the coordinate is the y value. So again, you can choose to use colors if you so please. We line up our point C with the y-axis, the orange line, and we can see that we are sitting at a height of -4. So we then put -4 into the second slot of our coordinate, and there you have it, grade sixes, or sorry, grade sevens. We are now comfortably able to find the coordinates of different points on the Cartesian plane, or what we call the coordinate plane, right? Now, we practiced a lot of this last week, so I'm not going to do more of this now. But let's say, for example, I decided to add a point D, right? Let's say this point were up here. So we know that we have point A over here, and we have point D over here. If this were a solid line that we needed to now measure, how would we go about that, grade sevens? Right, let's say we have this line sitting on our coordinate plane as opposed to just single dots. Right, instead of having points A, B, and C, we now have line AD. Line AD. Right? So let's say I wanted to calculate the length of this line over here, grade sevens. How would I go about that? And this is going to become quite important, believe it or not, and I'll give you a hint as to why. Let's go ahead and take a look at another grid very quickly. Right. Here we are on a new grid. And let's say, for example, you were given the following. Oftentimes, we will find that our teachers have a tendency to incorporate geometry into this section of graphing, right? Into the coordinate plane. So, for example, over here, we now have a perfect square on our Cartesian plane, right? On our coordinate grid. Now, looking at this square, sorry guys, you could be asked to do the following, right? Let's say at the top left over here, we have point A. Top right is point B. Bottom right is C. And bottom left is D. We would call this square A, B, C, D. Right? This is how we learn to name things as we move into high school. So you might be given a few different questions. For example, you might be asked to find the coordinates of these 4 points, right? The coordinates of all four of these points. Now, that we already know how to do. But what happens if your teacher says to you, calculate the length of line AB and line BC? Right. Now we start getting into the more intricate sorts of calculations that we can do when we look at these Cartesian planes or what we call coordinate grids. So you could be asked to do the following. Calculate the length of line AB and BC. Calculate the length of line AB and BC. In other words, the yellow highlighted line and the orange highlighted. In order to do this, guys, we actually do have to start by finding the coordinates. But because a lot of you already might know how to do that, I'm going to give you these coordinates. Right. Point A has the coordinate 7, 3. B has the coordinates 8. Sorry, guys, I already made a silly mistake. 3, 7, 3, 7. And point B is coordinate 8, 7. Point D will have the coordinates 3, 2. And C will have the coordinates 8, 2. Now, looking at this um, grade 7, I want you to notice something interesting that's happening when we look at the four coordinates or corners of this shape. As we move from left to right, do you guys see how the y value stays the same? Right? It stays the same as we move from here to here because we are staying level, flat. We stay at a height of positive 7. When we look at DC across the bottom over here, the same thing is true. Our y value does not change. I started at a height of 2 over here, and I end at a height of 2 on the other side of my square, right? And if we look at the vertical movement, as I move from point A all the way up here, um, across to point B, we can see how my x value changes from 3 to 8. And the same thing happens at the bottom, from 3 to 8, right? So because we're working with flat lines, we are not changing the height we are working at. For example, working with some funny shapes like this. We can see over here, we start at a height of just over -5, then -2, then -7.5, then -6, right? We keep changing the height that we are working with. But in our example over here, in the square, you can see that our lines are completely flat, right? Completely horizontal and completely vertical. So let's take a second to think about what that means for calculating the length of lines on this Cartesian plane or this coordinate grid. Let's start by thinking about horizontal lines. Right. If I have a line, for example, moving from left to right over here, just as an example, I start over here and I end over here. I am going to calculate the length of horizontal lines by taking the big X value and I minus the small x value from that. Sorry, guys, one second. For horizontal lines, you will find the length by taking the big X value and you subtract the small x value. Right, so let's take a look at this line that I've drawn over here on the right-hand side of the screen. Ignore this for the time being, guys. If I look at this line over here, I can see that it has a starting point on the left here and an ending point on the right. So let's find the x values. I can see that I start at an x value of positive 3 and I end at an x value of positive 10. All right. We start at 3 and we end at 10. If I take the big value minus the small value, I'm going to have 10 minus 3, which gives me a length of 7 units. Now we can count this if we need to. 1, 2, 3, 4, 5, 6, 7. There are definitely 7 steps between these two numbers. So, if that's how we calculate the length of horizontal lines, how will we go about calculating the length of vertical lines? Let's think about vertical lines. We're going to take, instead of using now the big X value and the small x value, we're going to use the big Y value minus the small y value. Okay, so if we now look at a perfectly vertical line on our grid, for example, grade 6, grade 7s, let's say we had a line that looked as follows. Right, there's our vertical line, and we want to calculate the length of this line. How would we go about doing so? Well, again, we need to consider that this is a vertical line, right? We are changing the height that we are working at from one point to another. So we need to take a look at our y values on the y axis. If we look at a starting point and an end point, it doesn't matter which you consider which, but what does matter is knowing which is the bigger and the smaller value. It's clear that at the bottom we are at a height of positive 1, and at the top we are at a height of positive 5, right? Now, if we were to complete this in the form of a calculation, what would that look like? Right. We take the big Y value. What is the bigger Y value of the two here, guys? Well, remember we said we have +1 and +5. So the big value is 5, the smaller value is 1. So we are looking at a length of 4 units. And again, if we count 1, 2, 3, 4 is the correct length. It definitely is 4 units long. Okay, so this is how we go about calculating lengths on this kind of a grade systems. And I'm not actually going to be going into more detail than that, guys. I haven't seen any questions from anybody just yet, but it's not super complicated. Let's go back to the beginning over here and quickly write one or two notes. Because I know that you guys won't be able to copy down all of these different examples that I want to draw. So instead, I'm going to show you guys a quiz that we can use to practice this. But let's write one or two notes first. Number one, calculate the length of a vertical line, or let's start with horizontal, sorry, of a horizontal line. What do we need to do? Point A, the first step we want to make sure we follow is to find the x value, right? We are talking about horizontal lines. We need to find the x value of the start and end point. The start and end point of the line. Then we are going to take the big X value minus the small x value. And then make sure that you write your answer with the word units. Okay, we put the word units at the end because usually these grids are not created with specific centimeters or millimeters in mind. So universally, we just have a tendency to use the word units. Then, to calculate the length of a vertical line, because a vertical line moves up or down, we want to worry about the y values, grade sevens. Sorry, guys, I've just finished teaching the grade sixes. So you are going to find the y value of the start and end point of the line. So what are we going to do once we've found these y values? We take the big y value and we minus the small y value, grade sevens. Okay. And again, just like we said earlier on, you want to write your answer with the word units. Now, if you guys have stuck with the color theme that I've decided to use throughout the last few lessons, associating X with yellow and Y with orange, you guys are more than welcome to obviously continue highlighting your notes in such a fashion to continue that theme, or continue using colors that you have used consistently in previous lessons, grade sevens. Okay, but there are keywords. And guys, if you can really understand this section of work, you are setting yourself up super, super well for high school. All right. So this is all I want us to write down, guys. Now, some of you might be thinking to yourselves, okay, so we know how to find the length of a vertical line and of a horizontal line. But what happens if we have some kind of diagonal line, right? A line that's sitting at some or other angle. That's a good question, guys. Unfortunately, that's a question that you guys will learn the answer to in grade 8. All right, we are only worried about perfectly vertical and perfectly horizontal lines. I'll give you guys 1 or 2 more minutes to copy, guys, and then, like I said, because today's lesson is expected to be quite short, I'm going to go ahead and show you guys what iRainbow has for you as far as this topic is concerned, so that if you guys want to go and practice, you can. I know that there are also going to be other people that eventually watch this recording that will also want to be able to practice this work on iRainbow. So I just want to give you guys an idea of where to find everything. All right. I'll give you guys 2 minutes to finish copying. And if you have any questions, please make sure that you ask. I am ready to answer any of your questions, guys. But like I said, you've got 2 minutes now, and then I am going to change screens in order to show you iRainbow. Right, guys, I am keeping my eye out for any messages, so please don't be afraid to ask using the comment box if something is on your mind. Right, guys, so let's go ahead and take a look at what quiz we can use to test ourselves on this sort of work. I am going to be changing my screens. If you need me to go back to something so that you can finish copying, please let me know. But let's quickly take a look at iRainbow very quickly. Right. So, guys, when we open up iRainbow, first things first, please make sure that you keep your iRainbow up to date, guys. It is really important. But once we've opened up iRainbow, we can go ahead and click on the topic at the bottom right, this chapter called measurement, right? We're going to click on measurements, and then we're going to go to the same topic or same set of quizzes that we've been working our way through over the past couple of weeks. So we're going to click on measurement, coordinates, find your way. Now, on here in this section, there are a few different quizzes that you guys can go and try. But unsurprisingly, guys, the ones that you might want to take a look at specifically to practice today's work is going to be the one called distances on a graph. I would strongly recommend you do level one before you try and do level two. Question number one, for example, asks us what is the distance between the first point and the second point? 5, 6, and 9, 6. Right? If we had to draw a solid line connecting these two dots, what would the distance between these dots be? Well, we can see that our y values stay the same, right? Because we're staying at the same height, which tells us that this is a horizontal line. But if we think about the notes that we just took down, we need to take the big X value, which is 9, and the small x value, which is 5. And we're going to subtract 9 minus 5 is going to give us an answer of 4 units. But the other way that we can look at a question like this is by simply counting the number of steps that we need to take between 2 points, right? So if we start at 5, we would say 1, 2, 3, and 4. We take 4 jumps, so there are 4 units between the point 5, 6 and 9, 6. All right, I hope that makes sense. So you can press submit. I would strongly suggest you guys write down an example of a calculation like we did in our practice example, because it'll help you to practice um, recalling information on how we calculate the lengths of different lines. So let's take a look at example number 2. What is the distance between the point 3, 7 and 3, 2? Over here, we have 3, 2 and 3, 7. If we wanted to connect these dots, we would use a vertical line, right? We can see that the change in position is because we've moved up or down. So, because we know that we are working with a vertical graph, we want to think about the y values, the second number in each bracket. We're going to take the big y value minus the small y value, which is going to be 7 minus 2. 7 minus 2 gives us an answer of 5 units. But again, if we wanted to count up or down, we would say 1, 2, 3, 4, 5, and the same would happen in the opposite direction. So we can see that our answer makes sense. Please note, grade 7s, that this sort of trial and error process of counting step by step is only going to work for perfectly vertical lines and perfectly horizontal lines, right? If I connected these two dots and my line was a little bit skewed, I would not be able to count just using grid squares like this. Okay. That's obviously a little bit more complicated, and you'll talk about it next year in grade 8, but I'm just giving you guys a heads up. So you can see we press submit and we are right on the answer. So guys, I think that practicing this quiz, you'll see, will be great chance for you to learn about how we calculate distances using grid systems. But more importantly, it's going to help you really, really, really solidify the idea of finding an X value, finding a Y value, which one your X axis is versus which one the Y axis is, right? It's going to help you repeat information, and the repetition is going to do you guys nothing but good. All right. So, guys, please go ahead and try this quiz whenever you get a gap. I think it would really be useful. And when you've done that, guys, if you have taken a look at the other three quizzes, you can see that we are now done with this topic of work. All right. We are done talking about this coordinate plane. But like I said, this has taken three or so lessons. And unfortunately, this will all form a part of your um, high school maths next year as well. Okay, guys, I do apologize for my camera being a little bit full of nonsense. I'm not sure why it's doing that, so I've just disconnected it quickly, but you should still be able to hear me. So, grade sevens, that's really going to be it for today, guys. We have got nothing left to discuss in this lesson, but I hope that you guys have learned a little bit more about this topic and that you have found it interesting as well. All right, guys, I think that's going to be it for today's lesson. So if you have any questions, quickly type them into the comment box for me, please, so that I can answer them. And then we will be done for today. All right. Is there anything you guys would like to know, grade sevens? Anything on your mind that's bothering you? We are finishing early today, guys. Thankfully, we have only had to wrap up the rest of a topic. We haven't had to go into a lot of new work today. So take today as an opportunity to go and study maybe a little bit more. I know that a lot of you are going to be right in the middle of exams at the moment. I haven't seen any questions from anybody about the work that we've discussed or about exams. But guys, I do want to remind you that you are always more than welcome to ask questions. Okay. Um, Please make sure that if anything is ever on your mind during these lessons, that you ask using the comment boxes. Um, but our next lesson for grade seven will be next week again, guys. It will not be on Friday afternoon, but a time will be confirmed with you guys over WhatsApp early next week. All right. So, guys, given that there's no more questions and that we've gotten through everything that we need to today, I really hope that you guys have a fantastic evening further and an even better weekend ahead of you. And, guys, I look forward to seeing you again next week. If there's anything that you guys are really struggling with in terms of your studying and prep for exams, or you are still a bit confused about something that we chatted about today after doing the quizzes, please make sure you bring those questions to the beginning of next week's lesson. All right, guys. Okay, thank you so much, grade sevens. I'll chat to you all again next week, guys. Have a fantastic weekend. All right.